This is lesson 204, which focuses on chapter 5 of our electrical systems book, Conductors and Overcurrent Protection. As you can see there, we've got a lot of different articles, a lot of different objectives here that we're going to see. Again, it's kind of a general catch-all for conductors and overcurrent protection. Again, a little bit of a refresher, you might say. So electrical conductors can be bare, covered, or insulated. Frankly, I can't recall a time that I've seen just covered conductors, typically bare or insulated, but those are your three options as far as that goes. All conductors and cables are identified by their markings. They all have to have some kind of writing, or a lot of times this will actually be stamped into the wire jacket or insulation, or just printed on there. They got to tell us maximum voltage. They have different letters identifying the type of cable, the type of insulation. So manufacturer's info we're not usually too worried about. We are almost always worried about the size, and usually AWG or circular mill, and then the cable assembly, as far as what it's made up of, right? What wires are in that if it's a cable. So ambient temperature and conductor heat contribute to insulation degradation. At the end of the day, this really boils back to 310.15b2a. That's going to be our ambient temperature derating factors, of course. This is a good one. I don't think is often thought about, especially in our area. We don't do a lot of very high buildings, but the weight of the conductor shall not be passed on to the conductor termination. So you don't want, if you've got a run running vertically, all this weight where the conductors are just hanging in these terminations, and that's what's actually holding the wire from falling back down through. Naturally, that's going to be a bad thing for your connection integrity, right? So they actually have a plug or sort of a wedge. Again, we don't see a ton of these, but there is a product out there, specifically to help avoid this issue, right? Listed twist-on wire connectors are available for directly splicing aluminum to copper. We should know by now we can't put dissimilar metals together in an electrical connection, especially copper and aluminum. There are specifically listed, they actually have some wire nuts here, but there's a whole bunch of every terminal and termination point is listed for copper and or aluminum, and then there's specific ones that are listed for both. And usually there's some type of a compound or a paste or a liquid or something that goes in there too, right? Re-identification of multi-conductor cables is permitted during install where the conditions of maintenance and supervision ensure that only qualified persons service the install. Basically, they're saying we can mark a white wire in a cable to do something other than be a neutral or a grounded conductor, right? In this case, they're doing a motor. And again, maybe you pull some MC or some Romex to it. So you've only got certain colored cables in that cable. Your white may not be a neutral in that case. Again, you think about switching for 3 ways, 4 ways, things like that. We are permitted to re-identify certain conductors to do other things, right? So each set of parallel conductors shall meet 5 conditions. So if we are going to run a parallel set of wires, or a parallel set of conduits or cables, whatever, which happens all the time, we have to make sure 5 things are met. Number 1, they're all the same length. Number 2, they're all made of the same material, so you couldn't run one parallel set is copper, one is aluminum. Number 3, they've all got to be the same size, got to be the same insulation type, and the same termination. So basically, they've got to be the same. Reason being, we know electricity takes the path of least resistance. If one of these is copper and the other are aluminum, copper has a lesser resistance, so more current is going to be imposed on that copper run. Same thing with the size, larger conductor offers lesser resistance. So again, the conductors just have to be the same throughout in a parallel run in almost every way. Derating of parallel conductors is determined by the design of the electrical distribution system. Again, we're talking about 310.15b3a at this point, which is our derating if we have more than 3 current carrying conductors. Electrical installations are classified according to their temperature rating. So they give us a list here. Again, we talk about 60 degrees Celsius, 75, and 90 degrees Celsius. Various insulation types are rated for different temperature ratings, right? And again, you're going to find this in 310.15b 3a, which is essentially your ampacity table. But we've got the 3 temperature columns. It tells us which insulation type belongs in which temperature column, right? All grounded conductors are not neutrals. This is something that's going to come up later on in the year. We talk about different voltage systems, different transformers. So in this case, they show us what's called a corner grounded delta system. So we actually have A phase, B phase, C phase, or 3 hots, however you want to look at it. One of these hots is actually grounded, which I know sounds bizarre, and it is. The nickname for this system is the dead man's leg because, if you meter this leg to ground, you will get 0, but it is in fact a hot. Again, much more on that later in the year. It's a very uncommon system for obvious reasons. That nickname doesn't bode very well. But just a quick word of caution, not all grounded conductors are going to be neutrals. Okay? We're going to get into tap rules here. So the 10-foot tap rule permits tap conductors to be supplied from a feeder without overcurrent protection at the point where they receive their supply, provided 5 conditions are met. So I think where you see this most is kind of like maybe a service where there's multiple panels or main disconnects off of one service. If you think about it, those what they call the tap conductors, so sort of this small section here, this small section, really don't have any overcurrent protection until they hit the sort of main breakers here. But anyway, so if we're going to do a 10-foot tap rule, basically it's 240.21b1. We have 5 things we got to abide by, right? Tap conductors are 10 foot or less. Tap conductor ampacity cannot be less than the combined load, cannot be less than the rating of the equipment containing an overcurrent protection supplied by the tap conductor. Number 3, tap conductors are do not extend beyond the panel board. Number 4, they are protected in a raceway, so we can't really have a cable at this point. We need extra protection because of the non-fused nature. Number 5, last but not least, line side overcurrent protection device is not to exceed 10 times the tap conductor's ampacity. That's kind of the big one. You want to make sure you're not getting tripped up on. That's a good one to remember, number 5 there. So similarly, we have a 25-foot tap rule. Okay, now we have 4 conditions that need to be met. Obviously, as the name implies, they're 25 foot or less. And again, this is 240.21b2. We just looked at B1, now we're on B2. Number 2, tap conductor's ampacity is not less than 1/3 of the rating of the overcurrent device protecting the feeders. They terminate in a single overcurrent protection device which limits load of tap conductors. And number 4, tap conductors are protected from physical damage. Again, similarly, now we're talking specific to feeding a transformer with this tap conductor. We have 5 rules to meet here. So number 1, primary conductor's ampacity is at least 1/3 of the rating of the feeder. Ampacity of secondary conductors times the ratio of primary to secondary voltage is at least 1/3 of the rating. That's a little bit of a complex complication. Primary and secondary are limited to 25 feet total. Once again, as the name implies. Tap conductors are protected from physical damage. And number 5, secondary conductors terminate in a single overcurrent protection device which limits the load to ampacity of conductors. And again, I don't think many of these sort of tap rules are a lot of people's first option. A lot of times it's existing or driven by necessity because, you can read these rules are kind of complex and winding, right? We can actually do tap conductors over 25 feet. Number 1, only qualified persons shall service the system. I think that should go for everything. Number 2, length is not over 25 foot horizontally and 100 foot total. So now we're essentially talking about if we have to go up or down a good ways, right? Number 3, tap conductors ampacity of at least 1/3 of the rating of the feeder. Tap conductors terminate in a single overcurrent protection device. Number 5, tap conductors are protected from physical damage. Number 6, tap conductors are continuous and contain no taps or splices. They got to run straight through. Number 7, tap conductors size at least 6 gauge copper or 4 gauge aluminum. Number 8, tap conductors do not penetrate ceilings or walls, etc. They basically contained in one room or area. Number 9, tap location is not less than 30 foot from the floor. So it's got to actually be up in the air. Again, they don't want anybody contacting this stuff, right? Because it is, in essence, non-fused wire. So now we have the outside feeder tap rule. One more tap rule here. Once again, we have five rules to abide by. Number 1, tap conductors are installed outdoors except where terminated. Number 2, conductors are protected from physical damage. 3, tap conductors terminate in a single overcurrent protection device. Number 4, overcurrent protection device is an integral part of the disconnecting means or located adjacent. And number 5, disconnecting means is in a readily accessible location near the point of entry. So, you're kind of thinking of maybe a service to an outbuilding, or in this case, kind of like one service comes in from the utility. We hit this building and then the next building. I've seen this situation many times with, say, mini storage buildings where there's several buildings. I've never used this outside tap rule. Again, I think this is somewhat uncommon. Again, it's kind of a pain to try to abide by all these rules, right? Okay, so now moving on to some overcurrent protection rules. We can't be in bathrooms or closed closets with overcurrent protection devices. Bathrooms for moisture reasons, closets for, if there's a spark on your Christmas sweater, next thing you know, the whole house is up in flames, right? So non-time delay fuses contain a fusible link that melts and opens a circuit at a set overcurrent. Time delay fuses can detect and remove a short circuit almost instantly, but allow small overloads to exist for a short period of time. So the name time delay means it's going to delay a certain amount of time depending on the overcurrent size. If it's just a small overcurrent, it'll put up with that. But if it's a short circuit, it'll open instantly. Whereas non-time delay, as soon as we hit that point, the link melts, the fuse blows, and the circuit's open. We have thermal magnetic circuit breakers. They contain both a bimetal strip and a magnetic element to sense overloads and faults. So it's almost two technologies built in here, right? One is going to sort of slowly open on an overcurrent, and the other will open instantly on a short circuit, right? Then we have inverse time circuit breakers that are available in single, 2, and 3 pole configurations. This is what we're all most familiar with. And again, the term inverse time means the higher the overcurrent, the shorter the amount of time it takes to open, and the lower the overcurrent, the longer amount of time it takes to open. So that's sort of your inverse time language there is what that really means. And then sort of last but not least here, circuit breakers are required to be clearly marked with info necessary to ensure their proper application. And those things are listed here as amp rating. Number 2, if 100 amps or less and 1,000 volts or less, circuit breaker shall be marked with the amp rating in the handle. Number 3, interrupting rating shall be marked except for 5,000 amps. Not entirely sure the reason for that 5,000 amps there, but number 4, circuit breakers used as switches shall be listed and marked SWD or HID. Think about a big warehouse where you're just using your breaker to turn your lights on and off. Essentially, that's just a wear and tear issue. A normal breaker is not meant to be turned on and off multiple times a day. And lastly, number 5, the voltage ratings shall be marked. So again, that was wrapping up here sort of a catch-all lesson, catch up on conductors, on overcurrent protection devices. Hopefully a lot of that sounded familiar. Spend a little time on those tap conductor rules because there are a lot of them. And as usual, don't hesitate to reach out with any questions.